Here we're going to take a look at simplifying polynomials by combining like terms. So before we just jump into the problems, let's make sure we understand what like terms are and unlike terms. So not like terms. So if you can't identify like terms or unlike terms, then you're going to have trouble combining like terms. Like terms are polynomials made up of like terms, where they're the same exact degree and variable. So meaning like if we had 3x to the third plus 5x to the third. These are like terms because we have the same degree on the term. So x to the third, same variable, x to the third, x to the third. So it's not necessarily 3x to the third and 5y to the third is the same because they're the same degree. It's got to be the same variable also. So like 5x plus 6x plus 7x. Those are all like terms because they all have x and they all have x to the first. Those are like terms. Unlike terms would be exactly what you might imagine, like the example that I gave before, like 3x to the third plus 5y to the third, where the variable is different. Even though the exponents are the same, that doesn't make them like terms. 5x to the second, y to the second, plus 6x to the second, y. Close. But this is y to the first. This was y to the second. Even though the x's are the same with the variable and the exponent, everything has to be the same. The whole entire term has to be identical. Same variable, same exponents, but that one's not, so that'd be unlike terms. Once we do have like terms, all it is, it's just combining them together, performing the operation. So like on number 11 here, we have negative 4x plus 7x. These are like terms because it's x to the first, so I'm going to do negative 4 plus 7. Which is 3. So 3x. 7 minus 4 is 3. So 3x. Number 12. X to the first plus x to the third. These are not like terms. So the answer would be the question, because I cannot combine those together. That's already simplified, technically. Now in 13, 7x squared minus x plus x squared minus 3x plus 5. We have multiple terms. And we do have some multiple pairs of like terms. I have 7x squared plus 1x squared. Those are like terms because they're the same variable with the same exponent. Then I also have negative x minus 3x. Those are like terms because it's x to the first and x to the first. So same exact variable, same exact exponent. And then I do have this plus 5 kind of tacked on the end there. That doesn't mean it's just going to disappear or anything. I just have to make sure I tack it on because it doesn't have any like terms with it. 7x squared plus 1x squared. I'm going to combine all the like terms now. So 7x squared plus 1x squared is 8x squared. And then negative 1x minus 3x. Those are like terms, so I'm going to combine those together. So negative 1x minus 3x is going to be negative 1 minus 3, which is negative 4x. And like I said, though, that plus 5 just gets tacked on at the end there because we don't have anything to combine it with. That's the foundation of combining like terms. You just identify like terms, you perform the operation that is being separated by. So let's keep going. Number 14. Negative 10x squared plus xy minus 5y squared minus 9yx. So we have negative 10x squared. Do I have any like terms with negative 10x squared? I go through each individual term. This is x and y. This is y to the second. X and y are not the same. This is yx. So no like terms with the negative 10x squared. Let's see, 6xy. Whoops, 6xy. Do I have a like term with that? Let's check. Y squared, not a like term. Yx. Xy and yx are like terms. The variables can be flipped around. Xy and yx can be flipped around. They're both x to the first. They're both y to the first. The order doesn't matter, though. Those are like terms. Those are going to be combined. And we have negative 5y squared. I have nothing to combine with that one. So I'm going to just combine the 6xy minus 9yx. So I'll have negative 10x squared. And then I'll do negative 6xy minus 9yx, which is going to be, so 6xy minus 9yx. And you could write it as 9xy if it helps you. Doesn't matter. But 6 minus 9 is negative 3. So negative 3xy, or yx, minus 5y squared. Number 15, we have this polynomial 4x to the third y minus 12x plus x squared y plus, and then we're adding on this entire polynomial here. So the parentheses here indicate that I'm adding on this entire polynomial to the first polynomial. So I'm adding these two polynomials together. you want to make sure that you are careful in this process and identify those like terms carefully. And you might want to underline, or sometimes I'll like underline one pair of like terms, then put a box around another, then put a circle around another. If I don't have multiple colors, like if you don't have like a pen and a pencil and a marker or something like that, just use different shapes to organize them. But you don't even have to do any of that. It's just kind of up to you. But I have 4x to the third y. So I'm going to look through each individual term and see if I have another x to the third, y to the first. So next one, x to the first, no. X to the second, y first, no. X squared, y first, no. X to the first, no. And then x to the third, y to the first. We have y to the first, x to the third. Is that the same? Y to the first, x to the third, y to the first, x to the third. Yes, it is. It's the order's flipped, but they're the same. So those are going to be combined. Negative 12x. Do I have a like term with negative 12x? I do. Minus 2x. Those are like terms. And then x squared y and x squared y. Negative x squared y. Those are like terms. I don't know what color I used here. Not purple. Oh, I think I used this blue. Yeah, I did. Okay. 4x to the third, y to the first, plus 10y to the first, x to the third. That's going to be 14x to the third, y to the first. Next, negative 12x minus 2x is negative 14x. Next, x squared y plus negative x squared y. So I'm combining these two. This is just looking at the coefficients. 1 minus 1 is 0. So I'm going to get 0. So that term is completely gone. 1 minus 1 is 0, so that term is completely gone. All I'm left with is 14x to the third y minus 14x. Again, this middle term here, x squared y plus negative 1x squared y. I'm looking at the coefficients. 1 minus 1 is 0. So I get 0x squared y, but that's just 0. 0 times anything is 0, so that term is completely gone. You just get 0. Let's keep going, just a couple more. On number 16, we have subtraction separating the two polynomials. 3x to the third minus 4x squared plus 5 minus negative 7x squared plus 11x to the third plus 8. So I'm subtracting off this entire polynomial here. Subtracting off this entire thing. Two ways of thinking about this. The first way is if I'm subtracting off this entire polynomial, I want to take the opposite of every term. So the negative 7x squared is going to become a positive. Positive 11x to the third is going to become a negative. 8 is going to become a negative 8. That's one way to think about it. Another way to think about it, and I'd probably steer you in this path just in case down the road, but if you want to also think about this as negative 1 times all of this, where you're distributing a negative 1 into here, and the only reason I'm bringing this up, like taking the opposite is completely fine, but the only reason I'm bringing this up is what if it was this? What if it was like minus 2 times negative 7x squared, and you'd have all this? What you'd have to do then is you'd have to take the opposite of everything, just like I was talking about, but then you'd also have to distribute 2 into the parentheses there, into the polynomial. So that's why I just like to introduce this concept of you could think about it as taking the opposite of everything, or you can distribute a negative 1 into here just so you can get familiar with that process of understanding that, well, it's negative 1 times all of that. What if it was a minus 3 times all of that? Then you distribute a negative 3, or minus 4 times all of that, you distribute a negative 4. So just a completely preferential step there. But I'm going to rewrite the first polynomial, 3x to the third minus 4x squared plus 5. Negative 1 times negative 7x squared is going to be positive 7x squared. Negative 1 times 11 is negative 11x to the third. Negative 1 times 8 is negative 8. Let's look for some like terms. I have 3x to the third minus 11x to the third. I have negative 4x squared plus 7x squared. And I have a 5 minus 8. Those are like terms. For some reason I can't see what colors I picked. Yeah, green. 3x to the third minus 11x to the third. 3 minus 11 is negative 8x to the third. Negative 4x squared plus 7x squared is going to be 3x squared. And 5 minus 8 is negative 3. There we go. Let's take a look at 17. keep this up on the screen here. So 17, same concept, just a little bit more difficult. We have just, the terms are a little bit messier, but we're still going to do the same thing, and negative 1 times that, negative 1 times that, negative 1 times that. So I'll have 7a squared b minus 5ab squared plus 6a squared b squared minus 13b squared a squared, because negative times 13 is going to be negative 13. Negative times negative 9 is going to make that a positive 9a squared b, and then positive 10ab squared. Go through each term. 7a squared b, 9a squared b, those are like terms. Negative 5ab squared, let's see if we have anything here, be careful. Negative 5ab squared is going to be this, 10ab squared. 6a squared b squared, negative 13b squared a squared, like terms right here in the middle. Don't let that fool you, they're just flipped around. 7a squared b plus 9a squared b is going to be 16a squared b. Negative 5ab squared and 10ab squared. 10 minus 5 is 5, so plus 5ab squared. And 6a squared b squared minus 13b squared a squared is going to be negative 7a squared b squared. Good problem there. Last one for this section, we just have kind of a word scenario. It says subtract 3x minus 8 from the sum of 2x plus 4 and negative 4x minus 5. So we want to take away 3x minus 8 from the sum of those other two terms. So be careful on how we write this. I always emphasize this whenever I'm looking at these sort of translation questions. Don't just translate this as like, oh, I see the word subtraction, I see this polynomial, so I'm going to do 3x minus 8 minus something, because I just see the order of how that's written. Make sure you know like how to actually do this. We are taking 3x minus 8 away from something. So I'm subtracting off 3x minus 8. I'm taking 3x minus 8 away. What am I taking it away from? I'm taking it away from the sum of 2x plus 4 and negative 4x minus 5. So I'm getting the sum of those two terms, and then I'm subtracting off 3x minus 8. So we want to do this problem individually here. So I have some like terms, 2x minus 4x, that's negative 2x. And then I'll just use a squiggle here. Hopefully I'll change the colors. 4 minus 5 is negative 1. And then we have minus 3x minus 8. So now we take away 3x minus 8 from the sum that we got on the original one. So now all we do is just distribute the negative. So we have negative 2x minus 1 minus 3x plus 8. Go through this a little quick. Combine like terms. Negative 2x minus 3x is negative 5x. And negative 1 plus 8 is 8 minus 1, which is 7, so plus 7. So if you understand the combining like terms portion, all it is, it's just making sure you're careful with the negatives. It's careful how you're setting this up, going from this statement here into an actual mathematical expression, being able to translate accurately. But if you're getting the concept of combining like terms, performing the operation, then you should be okay.